Welcome to the DIY Honda Garage channel. The DTC P04F1 indicates an issue with the Evaporative Emission (EVAP) system in the Honda Accord 2023 or newer model. This code is triggered when the Powertrain Control Module PCM detects low or insufficient purge flow within the EVAP system, which can lead to a failure to manage fuel vapors correctly. The components affected include the EVAP canister purge valve, the fuel tank, the FTP fuel tank pressure sensor, the EVAP canister itself, and the vent shut valve. All of these parts play crucial roles in minimizing emissions by allowing the engine to recirculate evaporated fuel vapor back into the intake air system. Locations of these components are scattered throughout the vehicle. The EVAP canister is generally located under the vehicle near the fuel tank, while the FTP sensor can often be found near or integrated with the fuel pump assembly. Identifying the issue addressed by this DTC is essential for maintaining emissions compliance and optimal engine performance. The DTC P04F1 specifically relates to the detection of low purge flow in the Evaporative Emission (EVAP) system. This system is designed to capture and recycle fuel vapors from the fuel tank to reduce emissions. Key components involved include the EVAP canister purge valve, which regulates the flow of vapor from the canister into the intake manifold, and the FTP sensor, which monitors vapor pressure in the fuel tank. The EVAP canister itself stores fuel vapors until they can be purged, and the vent shut valve prevents outside air from entering the system when not in use. The location of these components, such as the EVAP canister, often situated near the gas tank, is vital for understanding diagnostic tests and repairs. A malfunction in any of these components could trigger the code, indicating a malfunction within the system, requiring inspection and potential replacement of faulty parts. Several reasons may lead to the triggering of DTC P04F1. A faulty EVAP canister purge valve might fail to open or close properly, disrupting the flow of fuel vapors. Blockages in the purge line can also cause similar symptoms, preventing vapors from entering the engine system. The FTP sensor may malfunction, inaccurately reporting pressure readings, thus causing the PCM to identify a problem. Additionally, there could be defects in the EVAP canister, which may fail to properly store vapors. Lastly, if the vent shut valve does not operate correctly, it can create a vacuum leak or blockages that impair the overall system functionality. Each of these potential causes must be thoroughly examined to ascertain the exact origin of the DTC. The symptoms associated with DTC P04F1 can vary, from minor to significant issues impacting overall vehicle performance. One common symptom is the illumination of the dashboard warning light, alerting the driver to a potential issue with the emission system. Drivers may also experience poor engine performance, particularly during acceleration, as the fuel vapor system is crucial for efficient engine operation. Increased emissions are another concerning symptom, which not only affects the vehicle's ecological footprint, but can also lead to failing an emissions test. Additionally, an impacted EVAP system may lead to a fuel odor outside the vehicle, particularly after refueling. These symptoms highlight the urgency of addressing the underlying problems indicated by the P04F1 code. The first troubleshooting step in addressing DTC P04F1 involves preparing the vehicle for diagnostic testing. Start by turning the ignition to the on mode. This powers the vehicle's electronic systems without starting the engine, allowing access to diagnostic settings. Next, use the Honda Diagnostic System (HDS) and navigate to the Function Test section. By selecting the appropriate test for the EVAP system, it is possible to determine if the system is functioning as expected or if it is triggering any failure codes. Keep a close eye on the results displayed. If the test results indicate that the system fails to operate within specifications, it confirms that the DTC P04F1 is active and provides a basis for further inspection of the components within the EVAP system. The second troubleshooting step focuses on the EVAP canister purge valve itself. First, perform a detailed inspection of the valve for any blockages, corrosion, or physical damage that could prevent it from functioning correctly. It is important to ensure that the valve actuates properly. An improperly functioning valve could obstruct vapor flow and trigger the P04F1 code. Verify the valve's operational integrity by conducting a functional test as per the specifications outlined in the diagnostic manual. Any abnormalities in its operation, such as leaks or sticking, indicate that this component is likely the culprit for low purge flow. A thorough check of the valve ensures that there are no interruptions in the emissions control system. Continuing with troubleshooting, the third step involves a visual inspection of the EVAP canister purge line. First, visually examine the line for any signs of damage, such as cracks or wear that could lead to a loss of vacuum and therefore a loss of efficiency in the EVAP system. It's also essential to check that there are no blockages within the line, as any obstruction can lead to low or zero effective purge flow, directly contributing to the P04F1 code being generated. Properly functioning lines facilitate the smooth passage of fuel vapors from the canister to the intake manifold. Pay close attention to the integrity of the connections at each end of the plumbing, as poor connections can also be sources of leaks or airflow interference. The fourth troubleshooting step centers on the functionality of the FTP sensor. Begin this process by ensuring that the sensor is properly connected. Then, verify its operation by conducting a diagnostic check. This involves measuring the sensor's output under specific conditions, where the sensor should indicate consistent values when pressure is applied. Carefully monitor the data displayed on the HDS, Honda Diagnostic System, for inconsistencies. Differences in current and recorded values suggest that the sensor may be malfunctioning. The FTP sensor is crucial as it helps the PCM monitor vapor levels in the system, and a failure in this sensor could contribute significantly to the emergence of the P04F1 code. Hence, accurate testing is vital in isolating faults. The fifth step in the troubleshooting guide is to perform a thorough inspection of the EVAP canister itself. Since the canister is responsible for storing fuel vapors and its integrity is crucial to the functioning of the EVAP system, any problems here will directly impact purge flow. Utilize a vacuum testing procedure to check for leaks. Connect a vacuum gauge to the canister and apply a measured vacuum to observe how well the canister retains it. If the vacuum cannot be maintained, this suggests a leak that must be addressed. Identifying problems within the canister at this stage is critical, as failing components here can lead directly to the low purge flow that triggered the P04F1 code. In the sixth troubleshooting step, if previous inspections have ruled out other components, focus turns to the vent shut valve. This valve plays a key role in controlling air entry into the EVAP system. If the valve fails to open or close as intended, it can compromise the entire system, causing low purge flow detection by the PCM. To confirm whether the vent shut valve is operational, perform a functional test by observing the valve in action and checking for any signs of sticking or malfunction. If the previous evaluations have indicated normal conditions in other components, it's likely that the vent shut valve is at fault and will need to be replaced to resolve the P04F1 DTC. After completing repairs for DTC P04F1, the final step is verification. Start by clearing the DTC from the Powertrain Control Module PCM, removing any temporary fault codes that were stored during the diagnosis. Next, conduct a test drive under varying conditions to observe whether the vehicle's performance remains normal, particularly concerning emissions control. Pay attention to whether the dash warning light reappears during or after the drive. If the P04F1 code does not recur, it suggests that the repairs have been successful and the EVAP system is now functioning as expected. If the issue persists, further investigation into other potential causes will be necessary. Preventive maintenance is essential to avoid the recurrence of DTC P04F1 and to ensure the longevity of the EVAP system. Regular inspections of the EVAP components should be scheduled, focusing on identifying wear or damage early, particularly to the purge valve and hoses. Additionally, replacing worn or damaged components promptly will help maintain system functionality and efficiency. Keeping electrical connectors clean and secure is also vital, as loose or corroded connections can disrupt the operation of various sensors and valves within the emission system. By implementing these preventive measures, vehicle owners can significantly reduce the chances of triggering DTC P04F1 in the future. In conclusion, understanding the significance of DTC P04F1 is crucial for maintaining vehicle performance and emissions compliance. The troubleshooting techniques outlined provide a structured approach to identifying and resolving issues within the EVAP system effectively. From the initial diagnostic checks to final repair verifications, comprehensive understanding and methodology are key to ensuring a successful resolution. Recognizing the importance of preventive maintenance can further enhance system reliability, preventing future occurrences of similar trouble codes. By staying proactive, vehicle owners can ensure their Honda Accord remains in optimal operating condition and compliant with environmental standards. Please like and subscribe to the channel. See you next time.